Students, this is the next question we have. Here we can have multiple answers. So this question says, consider the following reaction where X is the substituent, X can be. This is the reaction we have where we have electrophilic aromatic substitution. Substitution of chlorine is taking place at para position. So we need ortho or para directing X. So methyl is ortho and para directing, Cl is ortho and para directing, NH2 is ortho and para directing, also C2H5 is ortho and para directing. Hence, the correct answers for this question are option A, B, C as well as D. Now let's move to the next question. This is the next question we have. It says the correct statement regarding E, F and G will be. Students, here we can see E, F and G. We can see here E and F are tautomers of each other. Similarly, E and G are tautomers of each other. While F and G are geometrical isomers. You can see here they are geometrical isomers. So we can write here they are tautomers and these are geometrical isomers. So let's go through the options. The first option says E, F and G are resonance structure, which is wrong. E, F and G are tautomers. So this is right. F and G are geometrical isomers. This is also correct. If I talk about D option, F and G are structural isomers. This is wrong. So the correct answer for this question are option B and C. Now let's move to the next question. This is the next question we have. It says identify the correct order among the following molecules according to the given property. First order is given for order of heat of hydrogenation. Students, if I have a less stable alkene, it will have higher heat of hydrogenation. So if we compare them, this is the correct order of stability on the basis of hyperconjugation. This is the most stable alkene here and this is the least stable alkene here. So here the heat of hydrogenation order is given correct. If I talk about B statement, here it's written order of heat of combustion per carbon atom. If the compound is less stable, its heat of combustion per carbon atom will be more. So as we know, cyclohexane has highest stability among cyclohexane, cyclopentane and cyclobutane. So it should have least combustion per carbon atom. So this cannot be the correct order. If I talk about C option, here it's written order of resonance energy. So we can see here the maximum resonance will be observed here, then here, and the least resonance will be observed here. So the maximum resonance energy will be the structure 1, then 2 and then 3. So this is the correct order given. Why? Because of the conjugation. Here we can see extended conjugation. Here we can see cross conjugation. Here we have only one conjugation. So we can have the order of resonance energy as given in the, hence the correct answer is option C also. If I talk about D option, here we can see we have 3 structures. Now these structures can be compared on the basis of the stability of conjugate acid formed. Let's write their conjugate acid. If I talk about the first structure, the conjugate acid will be this. Similarly, in the second structure, this will be the conjugate acid. In this third structure, this will be the conjugate acid. Now, among all 3 conjugate acids, this one will be most resonance stabilized than this, and this will be least resonance stabilized. There is no resonance. So, conjugate acid stability will give us the order of basic strength. So, this is the correct basic strength order. Hence, the correct answers for this question are option A, option C, and option D. Now, let's move to the next question. This is the next question we have. It says, what is the correct sequence of reagents used for the following conversion? Students, here we have cis alkene which converts to trans alkene. So if I consider this order H plus and H2O, so here addition of water will take place and then H plus heated. So on heating, this will give us elimination. So first we are adding water, then eliminating water with an acid. So This will give us the trans alkene. So A is correct answer. If I talk about B option, first of all we have hydrogen and nickel. It will give us butane. Butane, when reacts with bromine in presence of sunlight, it will give us 2-bromobutane, which on reaction with alcoholic KOH gives us trans alkene as the major product. So this is also correct sequence. Now if I talk about C option, here we have Br2 and CCl4. So Br2 and CCl4 will give us anti-addition of bromine. So Br will be added. When we use 2 equivalents of sodamide NaNH2, it will eliminate 2 moles of HBr, giving us which will be 2-butane. Sodium and liquid ammonia gives us trans alkene on reduction of but2-ine. So this is also the correct sequence. Then we have Br2 and NAI acetone. In this case, cis alkene will be formed again. Hence, this is not the correct sequence. Therefore, the correct answers for this question are option A, option B, and option C only. Now let's move to the next question. This is the next question we have. It says, which of the following alkene will give the same product on hydroboration oxidation as well as on acidic hydration? So students, if I talk about option A, on hydroboration oxidation, it will give us (2-methyl cyclohexanol), and on acid hydration, it will give us Markovnikov addition product, which will be 1-methyl cyclohexanol. So these two products are different. In all other cases, if we write the products, both will be same because the positions are identical. So hence the correct answer for this question will be option B, option C, and option D. Now let's move to the next question. This is the next question we have. It says, which of the following statement or statements is are wrong? If I talk about the first statement, it says coal-based electrolysis method is used for preparation of alkene and alkyne only. Students, this is a wrong statement. Why? Because coal-based electrolysis method can be used for the preparation of alkane also. So alkane is also formed in coal-based electrolysis method. If I talk about B statement, it says by the use of Grignard reagent, which is RMGX, an alkane with odd number of carbon atom can be obtained by hydrolysis or by nucleophilic substitution method. Students, if I talk about RMGX, alkyl magnesium halide, we can form an alkane with even number as well as odd number carbon. So this B statement is right. If I talk about the C statement, it says Wood's reaction is used to prepare the alkane containing odd number of carbon atoms. Students, statement C is wrong because by Wood's reaction we can form the alkane having even number of carbon atoms only. If I talk about the D statement, it says benzene has bond order 1.5 between carbon atom. This is a right statement. Benzene has bond order 1.5. So the correct answer for this question are option A and C only. Now let's move to the next question.